Hello everybody and welcome back. We are going to continue our discussion about strings by talking about a class that Java gives us known as the StringBuilder class. If you go to Java Oracle documentation on StringBuilder, you will find that there's a whole class here with lots of interesting information and different ways to utilize this class, and we're going to talk about some of these in this video today. Now, as we discussed in the last video, imagine for a second that you'd be writing a book or making changes to a document, and every single time that you do an edit, you have to recopy over everything just to add a sentence or make a change to a character. That is how Java strings behave, and we saw that in the last video. It would keep creating new copies of everything constantly. And StringBuilder, this class I'm talking about now, is going to help us fix that. It's going to let us edit the same string, the same book, as it were, instead of starting over each and every time. All right, let's go ahead and take a quick reminder look at a string example here. I'll go ahead and make my class main, public static void main. All right. And let's just make a string s equals to blank for int I is equal to 0, I less than 5, I plus plus. Guess we'll do it like this, and then at the end we can print out system.out.println our final s value. Let's see if Python Tutor can actually showcase this the way that I want to. So we're going to go ahead and create that empty string, and then we're going to go and create a new string on top of that one, and a new string on top of that, and a new string on top of that, and a new string on top of that. Each of these is giving us a new memory allocation. Now, it isn't particularly obvious based on this imagery, but the reality is that this string is indeed being created as a new address with one tiny tweak made, and then the old one is being thrown out. And this is expensive. This is incredibly inefficient for us to be doing, and especially on large scales, all of that memory management can be a real waste of time and may really slow down your programs. So we have access to StringBuilder instead. This is going to be our alternative. And we'll even do some timing later to really drive this home. So we use StringBuilder just like this, the StringBuilder class, and then I'm just going to call my variable SB, which stands for StringBuilder. But as always, your variable names are your own. And then I'll go ahead and make a similar loop. Now the difference is, of course, my StringBuilder is basically a class that's wrapped around a string. We're like hugging a string inside the StringBuilder class. So what that means is we can't use a concatenation directly. We can't use the little plus to make edits to our string. Instead, what we use is a method .append. And now each time we are going to append another character on to our string. So previously, this line was S is going to string S was an empty string. This is basically going to give us an empty string, just it's sort of nestled inside this StringBuilder class. Once we have finished our loop, we can go ahead and print out whatever is inside of our StringBuilder variable. So inside the StringBuilder object, we can go and grab the toString. We don't actually have to call toString directly, but we can, and we can see what actually happens in here. Let's go ahead and run this code. So what we'll see happening now, once we get in there, is that there isn't additional memory allocation happening because we don't actually see the object being changed through each iteration. It's sort of all hidden away underneath this Java Lang builder instance. But at the end, it will still spit out our same information of that string. So this is perfect for loops or heavy text construction. And now there are lots of different methods that are available to us through StringBuilder. You are always welcome to go and look at the StringBuilder documentation and review all the different methods that you have available to you. So the one that we just used was append, and we appended an int I. So if we go and look here, we can find append int I, and we can see it appends the string representation of the int argument to the sequence. We can see that this append method is overridden by many other versions: a double, a float, a long, objects, string buffers, lots of different ways for us to interact with this StringBuilder object. Now, there are other methods that we have access to as well. And again, you can go through those docs, but I will also show you some of them here. We've already seen append. So let's go ahead and just simplify this code a little. We'll just say sb.append. Actually, why don't we start off our string with the word hello in it, just to see that that's a thing we can do. And then in here, we can add world. And we've seen this already, right? We have seen this dot append. And now just to prove you don't have to write the toString, I'll put this in here with no toString. Just for one more example, I'm just going to click right through to the end and we'll see, yes, indeed, hello world does print out. Okay, the next method that we want to consider is going to be insert. For example, sb.insert 5 Java. Got to get rid of this for a second. There we go. And let's print this out. What does this insert actually do? We'll go ahead and visualize that. The main idea here is that we can now add text into a specific position. Ta-da! I guess I didn't need the exclamation mark. That looks kind of dumb. Hello, Java. There. This will look maybe less dumb. We can see that it injected it right in between. It didn't overwrite what was there. It just sort of squished its way in between the two words, starting at index 5. Now, previously, we had to use some sort of combination of substrings and charats and index of to find the right position that we want to do this at. This is going to solve that problem for us a fair bit. The next one we're going to look at is, I better put some comments in here for those of you who are sort of tuning in and out. Insert. All right, the next one that we can discuss is delete. And as you might expect, delete will remove a slice of the words from the string. So if you want to delete the first word, we want to remove character 0, 1, 2, 3, 4, and maybe this comma, 5, and maybe this space, 6. We can go and delete up to 7. This is going to be inclusive to exclusive, just like substring, just like index of, all the things we would know how to use. And then when we run this one, we'll see that we did indeed cut out this hello, comma, and space. So we have kind of like a splice, like what exists in Python, without having to do any substrings and concatenations on our own. The last one we can look at that's just for fun really is reverse. And if we call sb.reverse and then print it out, it will indeed give us a reverse, it will indeed reverse our string. Ta-da, right there, it's reversed. Now it is worth noting that this is a little bit different. We are directly manipulating the value of the StringBuilder string. There's no return value. So unlike when we were using dot substring and dot index of and all of those functions with our strings, those did not affect our variable directly because strings are immutable. However, objects such as StringBuilder are mutable, which is the whole point. But it is important for us to remember that that's the case, because now when we call things like sb.reverse, there is no return type. It will directly affect it. So now we can see that we have one object with many changes. So now we want to actually compare our different running times between StringBuilder and string concatenation. So what I've gone ahead and done is I've created a little program to do this. This program won't actually run in Python Tutor. It's too large of an example for Python Tutor to work with. So I have gone and written it in my own IDE right over here. You can see this is the whole program. It's not very long, but you can pause here and record and like copy it all out if you want to try it out for yourself. The way it works is we start here on line 3, where we record the current time of the system when this is running in milliseconds. We will go ahead and do our string concatenation, and then we will take another timestamp of the time after we have completed our string concatenation. Then we will just print out the end minus start time, and we will get how long the string concatenation took of 10,000 elements in milliseconds. I will then go and do the exact same thing again using those same variables, start and end, only now our functional code that we're trying to wrap the timing system in will be 10,000 StringBuilder appends. And then once that's completed, we'll do the same thing. We can go ahead and print out StringBuilder. Now I'll do my writing, I'll do my compiling here in Terminal. You can use whatever you comfortably normally use, and that's totally fine. So across 10,000 elements, we can see that the string concat took about 37 seconds and StringBuilder took about 0 milliseconds on average, right? It took it took microseconds. We can see that StringBuilder took microseconds. So what are we going to actually, gain? Gaining 37 milliseconds doesn't really seem like a huge difference. So let's change this from 10,000 to a million. There we go. That's going to be 1,000,000 elements that we are now going to be appending on either here in string form or here using the StringBuilder. So I will go ahead and make sure I save that. I will recompile it, and then I will go ahead and run it. Now this is going to take some time. We're going to leave it and let it run, and then continue our conversation over on the Python Tutor page. I have one-ish more things I want to show you here. StringBuilder, SB. Imagine for a second that we are building a string out of string builders, and we're going to do a lot of them. We need append to sb.append sb.append lots. There we go. We can see we have a lot of appends happening here. And then we're never using our string builder again. Once we've got this finished up, we are good to go. We don't use it again after this. Let's go ahead and run this code just for a quick second here so that we can see. I'll jump to the end. We need to append lots. It all comes out in a string. Now, this is okay, but if we're never going to use that string builder again, maybe we don't want to have to write all of it out like this. Instead, let's make a string result up here. And we are going to use something called chaining, where we will chain together all of these calls. So if I remove the semicolons from all of these, and I remove the SB from all of these, this will become one giant executable statement. Now, this is basically the same as before, only now imagine if all of these were like on one super long line. We're just separating it over lots of lines. And now after we say new string builder, do all of our appends, we'll turn it into a toString, and then that will get stored in result. This is a slightly cleaner way of using StringBuilder when we do have lots of appends that we're doing one after another, or if we have something really complicated that we're starting with that has lots of formatting, we will chain our appends together and we'll see we're going to get the exact same result when it comes out at the end. Now, it's worth noting that StringBuilder, when we do create a new string builder, just as we see right, here, that is going to actually take, there's lots of overhead that comes with allocating memory for a string builder. So if all I'm going to do is append 5 words together, like this example here, we need to append lots, and then print it out, there's no reason to be using StringBuilder because that's just extra overhead that we don't really need. The extra overhead is basically the same thing as just doing plain old concatenation as normal. But In a minute, we'll go back to my other example where we see the difference in concatenating 1 million elements together, and we will see that there actually is a great difference in timing when we sort of reach that scale of execution. So as a reminder, what we did see previously was about a 37 millisecond difference between strings and string concatenation and StringBuilder, and that was at about 1,000 elements. Let's flip back and check on our 1 million element program. All right, it's all done. Here's our 1 million element program. We can see here that the string concatenation took 180,528 milliseconds, and our StringBuilder took 24 milliseconds. So before, when we only saw, let's say, a 30-ish, 40-ish millisecond difference between the two different modalities, now we see a huge disparity in that timing. We can really see StringBuilder's efficiency shine through as our sort of input size space grows and grows. So that's pretty cool. And this kind of leads us into our next topic, our next video, where we're going to actually start to dive into reading from files. And files can be huge. So while up until now, we have been concatenating strings together like this, right? Line 11 up there, where it's just little sentences here and there. Once we start dealing with file manipulation, files come in all different sizes, very large, novel sizes, right? Data sets can be huge, and knowing how to use StringBuilder effectively will only make our programs cleaner and more efficient. I will see you in the next video where we will discuss all of that and more. Thanks so much. Bye.